Hi, today I'm going to be talking about my project for DSE 503. This is about predicting box office outcome of a movie. Um, as a movie fan, I always wonder why some movies perform really bad at the box office, even though the movie was perfectly made. Then I kept thinking about the different factors that could actually affect the way movie works out. Uh, Rather, I wanted to study the different attributes that are associated with a movie. I wanted to see if it gives me a good picture, if the analysis is going to give me a good picture. I actually conceptualized this as an exhaustive project where I wanted to build a huge model that would be trained based on the images, videos, the music, genre of the film, user summary, user rating, number of awards won by the movie, etc., etc. I think this is the first step for me in that direction, where I'm just focusing on um, just one parameter, which is the posters. What I'm envisioning is that building one-to-one correlation between the different features or the attributes to the box office revenue, and then combining all of them into one um, to see my hypothesis, so to speak, to come true. Um, so for this project, I used the data source from um, TMDB, the movie database. The pointer I got the pointer to TMDB from Kaggle, um, particularly Ronak Banik's data set. So he has um, he has gathered data from TMDB and has put everything in one place. So that was kind of easy for me to like take data from just one source. Um, the data, just to explain what is present in the CSV file or the data set. Um, it has it classifies if the movie is an adult movie or not. The movie ID, the title of the movie, the popularity score, the budget on which it's made, revenue that it made at the box office, which is our primary area of study in this. Um, so, although I had although I had this exhaustive data set available, I still needed to sort of double check certain things by just to make sure that the data is updated. I used TMDB's API calls to capture the revenue details one more time, just so that if so the way TMDB works is there are contributors who keep adding the revenue details or any detail of a movie. So I just want to make sure that excuse me, that the data that I'm using is actually up to date. So I use the movie ID to call the revenue of the movies, about 45,000 of them. And then I also had to use the poster paths that was present in the data set to download the poster images of the movies from TMDB. Um, I actually started with sequential processing. I didn't I wanted to see what the difference in timing, uh, rather how much time I'm going to save if I'm using parallel processing. Looks like I saved one. I would have saved 1/6 of the time if I just went with parallel processing in the first place. But just to compare, I could see that the sequential processing took about 2 hours and 36 minutes, and the parallel processing took 25 minutes and some seconds. So like when I'm dealing with such a large data set, I could actually see the benefits of parallel processing. Um, and I also tried to use parallel processing in um, like training my data set, but it just did not work out well for me. Rather, it did not work out the way I intended. So, yeah, and moving forward, I want to talk about, excuse me, the data cleaning part of this project. So, what I noticed was since it's a large data set built by um, API calls, built through API calls, there were many features which there were many values which were not as intended. Like for instance, there were a bunch of values in the revenue column that were not float. There were some characters in it. So I caused those data type as float, and then in the event of error, I printed not available, like not a number, NaN, which I eventually removed the um, from the data from the data set. Like I removed that entire row, which in which the revenue value is not a number. I took them out. And then I also thought it would make more sense if I were to normalize the revenue on a scale of 1 to 10 because sometimes the numbers go in hundreds of millions and sometimes it's like $100,000, hundreds of thousands of dollars. So in order to maintain consistency, I normalized the revenue column on a scale of 1 to 10 using this formula. So I actually went through some Medium articles about normalization and I tried this out and that gave me good results. So I just thought I will just keep it the way it is. So moving on to the model architecture, this is a shallow network with two convolution layers and three fully connected layers. Um, let's just get into the mathematical formulation. So the convolution operation is given by f of the weights times the input, which is x, plus the bias b. And then the activation function that I'm using here is ReLU, and then um, the pooling operation is basically the max of x. So basically, this layer takes an RGB image with three channels as input. RGB3 channels. Uh, and the max pooling layer reduces the spatial dimensions of the input by taking the maximum value over a 2 by 2 window. So this operation actually downsamples the feature maps, excuse me, reducing the spatial size by a factor of 2. So after the image passes through the convolutional and the pooling layers, the output feature maps are flattened into a vector, and they are passed through the fully connected or the dense layers. So just to visualize the network, this was generated this was generated using one of the PyTorch libraries to visualize how my network actually looks like. So the ADDMM backward 0 represents the backward pass for the fully connected layer. It actually computes the gradients of loss with respect to the fully connected layer 3, like the weights and biases of the fully connected layer 3. And similarly, the ReLU backward 0 indicates the backward pass through the ReLU activation function. And the accumulate grad actually represents the gradient accumulation for the respective parameters, like the weights and biases, during the backward propagation. Um, and then the convolution backward 0 indicates a backward pass through the convolution layer. So in the forward pass, the image is processed through the convolutional layer and then the pooling layer and the fully connected layers to produce the output. And in the backward pass, the loss gradients are actually computed starting from the back, like from the output layer all the way back through the convolution layer. So the gradients for each parameter here are accumulated, and that's what is basically used to update the model parameters. So the W and the matrices are um, accumulated when in the backward pass, and that is actually used to um, like that is used to fix the values for the network, like the weights and biases for the network. So this is the model training over the epochs. So I arbitrarily entered 50 epochs, but with early stopping. So I used the parameter called uh, patience. What it effectively does is that when the loss um, starts increasing um, o- over epochs, like as we see on the graph, the loss was very high in the earlier epochs, and then towards the 22nd, it actually reduces. So what the patient's parameter does here is that when the error has gone to a minimum, and then when the error starts to increase from that point, um, patients count as like the patient is a counter basically. So it was set to 0, so it increments by 1 each time that happens. So I've given the patients or the tolerance value of 5. So the fifth time it happens, the training stops, and it plots the training stops and it plots the training over epochs, and it also shows the model evaluation after training. So I had the usual test to training ratio of 80 is to 20, and um, it was trained using the mean squared error and that is a loss function. And then I optimized it using the Adam optimizer. Um, like I said, I did early stopping. I implemented early stopping just to prevent overfitting. And the evaluation of the model is as follows. The test loss is 0.0360. That actually started at I think um, around 0.59 something, and then the test loss was eventually reduced to 0.0360 with an accuracy of 89.1%. So what this means is that if I input an image of an upcoming, sorry, a poster image of an upcoming movie with 89.1% accuracy, it's gonna tell me what level between 1 and 10 that movie is going to follow. Um, and yeah, so this is the screenshot from this is a screenshot from the output. Despite the model having good accuracy, I still feel that this project has certain limitations and more um, upgrades, more work in the future. Um, so one of the major limitations is that I just used um, one type of data to analyze, or, or to put it in other words, I'm just using the posters to judge how good a movie's outcome is going to be. Um, However, this is just a part of the major effort that I've undertaken. So I think when I progress to other features, I think plugging this um, sub project, or rather plugging this information would give me more clarity in the analysis. Um, and then the second limit, the second point that I would like to work on is adjusting the dollar values for today's inflation. Um, and because um, what we could have done with $1 in the 90s or 2000s is not the same as today. So that was not a straightforward process because I had to normalize. So this data set of movies has movies from around the world and even across 93 languages. So it's a it's a bit of a tedious process for me to normalize the local currencies to US dollars and the purchasing power parity terms, and then normalizing them for today's or the 2024's inflation rates would um, actually give me the exact picture before, and then after that, I would normalize that inflation adjusted values on a scale of 1 to 10, so that it's that was taking more time for me, so I thought I would do that in the version 2 of rather the continuation of this project. Um, Another thing that I would like to do is trying out other loss functions and see if the model has a better fit or if it doesn't perform well. So it just to give me more um, clarity on what works best for this use case. Um, and then the last one is compensating for the loss of data. What I mean by that is in the process of taking revenue details from TMDB, I I observed that there were some values for some movies, the revenue was not available on the database. So, which meant that I had to find another source through Google search and add that corresponding value, um, just so that I can increase the um, number of data points that I have. So the more number of data that I have, um, more accurate it is going to be. So this was a, a bit of a challenging project um, because it was in my mind. What was in my mind was very clear, but the execution part was a bit challenging because uh, data were to be gathered from multiple sources, and everything was not available at one place, were not available at one place. And if not for Ronak and his movie project, I don't think I would have made this progress in this short period of time. Um, Now that I have access to those data, I want to advance this research into um, making the model more stable and more accurate than this. So, yeah. Thank you so much for your time. Thanks for watching the presentation towards the end. Uh, you have a good rest of your day. Bye bye.